where our total gets adjusted. All, and or always has the total out of our entire population or sample of 1,000 people. All right, so discuss the methods for finding the following two probabilities and explain the important differences in the computation. If one person is randomly selected, find the probability that he or she died of heart disease. Okay, how many people in our sample died of heart disease? Yes, 465 out of? Okay, and then we may want to write that as a decimal over here. Second part, if one person is randomly selected, find the probability that he or she died of heart disease given that he or she was a non-smoker. So we already know the given part tells us our prior information. Instead of looking at all of the people, we're only looking at the non-smokers. So which ones are our non-smokers? It's this entire row. These are our non-smokers. Of these non-smokers, how many died of heart disease? Okay, so what's our probability? 155 out of 350. Okay, and what is that? Let's round that. Is approximately 0.429. So what is the difference between our two questions over here? Yes, and I'm not really looking numerically, but what is the difference in our calculation over here? What did we do with the first one? We simply...
Well, the first one's the whole population.
Math is incorrect.
And
I
then
mean,
the
you
second
said
one,
right. Yeah, it's just 0.4429.
just on the second one. You forgot a 4.
4.
4.429.
Okay, maybe you know what, I miscalculated. 155, 350, 4. All right, we'll squish a 4 in there.
But it's just, the difference is just the whole population and then you
Yes.
the smaller population.
First one looks at the whole population. The second one looks at that additional information. We already know it's a non-smoker. Perfect. All right, so table probability. Please look at some of those examples we did because it is very commonly, a lot of people make mistakes there, especially with the totals. So if it says and or, you're going to do the entire total. If it says given, that's where you adjust. All right, number 5 is going to be a little easier than all the other questions. So this is kind of nice question here. A die with 12 sides is rolled. What's the probability of rolling a number less than 11? So you can start by writing out the sample space over here. And you have to know, less than 12 means actually less than 12, right? So the biggest it can be is less than 11, right? The biggest it can be is 10. So that is 10 over 12, which is 5 over 6. So this one's a nice and easy question, straightforward. Remember, probabilities are always numbers between 0 and 1, so that's another good one to check. Is your number a probability? If you end up with a negative probability or a number greater than 1, check your answers. All right, number 6. The data set represents the income levels of members at a country club. Find the probability that a randomly selected member earns at least 90,000. Round your answers to the nearest tenth. So at least means 90,000 or more. So how would we calculate that probability? Do what? Add them all together. Then we get an average, right? We want to know how many of them earned more. What percentage earned more? We're going to highlight the ones that are above, or at least 90.
So 90 or above?
90 or above, including 90. All right, so how many did we highlight over here? 14, out of 20. So 14 out of 20, that is equal to 0.7. So A would be our answer over here. All right, we're going to talk about question 7, and we had a little discussion in the classroom, so I actually redid this question for you guys. It says over here, if one of the results is randomly selected, what's the probability that it is a false positive, meaning the test indicates the person has the disease when in fact they don't? What does this probability suggest about the accuracy of the test? Well, when you look at your table, we have over here, the first row is all the subjects that have the disease, the positive and the negative test results. And then in the second row, the subjects does not have the disease, and again, the positive and the negative test results. So we are looking for the false positive, which is, if I highlight it over here, looking for a positive test result when the subject does not have the disease. So we're looking for these 27 people out of the total of 278. So when we divide 27 by 278, that is a probability of 0.0971. And so over here, the correct option is option D, which is the probability of this error is high so that the test is not very accurate. Here's number 7. We had a little discussion in class about this, so I actually redid this question. If one of the results is randomly selected, what's the probability that it is a false positive, meaning the test indicates the person has the disease when in fact they don't? What does this probability suggest about the accuracy of the test? Okay, so over here we're looking for all the people that have a positive test result and the subject does not have the disease. So we're looking for the 27 highlighted people who are both. And this would be a probability of A and B, and therefore we're looking for the overlap. So the 27 people out of the 278 total. So 27 divided by 278 is actually 0.0971, and therefore it's option D. The probability of this error is high so that the test is not very accurate. All right, let's look at number 8. Over here, find the mean of the probability distribution. We looked at several examples where you had to check whether it was a probability distribution or not. But over here it just says find the mean and the standard deviation. No, just the mean. How do we find the mean?
You can put it in a list, calculate it out.
Yes. Put X into L1, P into L2, and then calculate. This is the same way you would find the standard deviation, right? Or even the expected value. So go to Stat, Edit. Make sure you clear out your lists. Oh, and over here, let me put in, there's a missing list. Okay, list 1, we put in all the variables for our random variable, which is X. List 2, we put in the probabilities. Remember, each probability is a number between 0 and 1, and they all add up to 1. Now go to Stat, Calc, one of our stats, and using L1, comma, L2. It says the mean is 1.68. The standard deviation, remember with a normal, with our discrete probability distribution, since all the probabilities add up to 1, it only gives us the population standard deviation. So our mean is 1.68, which is C. Okay, number 9. Number 9 is a binomial distribution. When we looked at chapter 5 and chapter 6, chapter 5 was a discrete probability distribution which had, tables for some, and then the big one we had was the binomial distribution. With that, we can either use the binomial formula or we could use the binomial PDF, or some questions we use the CDF. In this example, it says use the binomial probability formula. So we're going to do it how it asks us to find it, but we'll also compare it with the binomial PDF. So n is 12, x is 5, and p is 0.25. What is q?
0.75.
Yeah, it's 1 minus 0.25, which is 0.75. So the probability that x is equal to 5, the first part, this is back to question 1 and question 3, was the NCX, so that's 12C5. So in how many ways can we have 5 successes among the 12 trials times the probability of the success? I'll get to your question in a second. 0.25 to what power? How many successes? 5. And how many failures? 7. If we have 5 successes, we have 7 failures. Question?
Or the Q equals 1 minus, is that 2, 5?
Is that what?
Yeah, it's 0.25.
Yes, it's 1 minus 0.25, which is equal to 0.75. So P and Q always add up to 1. Because binomial, we have 2 outcomes. If the probability of success is 0.25, then the probability of failure is 1 minus that. So calculating this out 12C5 times 0.25 to the 5th power times 0.75 to the 7th power is what? What is our example over here? So it's choice D, 0.103. If it didn't specify to use the binomial probability formula, we could have used the binomial PDF, right? So you can check your answers. What is N? 12. What's P? And then X. So maybe on your own, go check that answer and make sure it's the same. So if it doesn't specify how to solve it, you can use the binomial PDF instead. All right, number 10. A test consists of 10 true-false questions. To pass the test, the student must answer at least 9 questions correctly. Okay, true-false, what's the probability that any question is answered correctly? Yeah, 0.5 or 1/2. What's the probability that you get it wrong? It's again 0.5 or 1/2. You want to know what's the probability that you get at least 9 correct. So at least means 9 or more. Right? So really what we're looking for is 9 or 10. Okay, so we can use over here, it doesn't specify how to answer it, so we can use the binomial CDF over here. Or we could use the PDF of 9 plus the PDF of 10. Now, what is one thing you have to remember whenever it's like the numbers to the right? Use the complement. So write down, you're looking for 9 or 10. Since it's to the right, you're going to find the complement which starts at 0 and ends at 8. So complement means you have to do 1 minus. So 1 minus binomial CDF. So 1 minus because we're looking at the complement. CDF because we look at, these 9 different values. And then we enter in N. What's N? What's P? 0.5 or 1/2. And what is the largest x value in the complement?
8.
Right, use the 8 over here. Okay, so calculate that probability. And on the calculator, you can go straight into 1 minus binomial. So that's the second vars, brings you to the distribution. Going up to binomial CDF, entering in first the number of trials, then the probability, and then the largest x value, which was 8 in our example. And the probability is 0.011 rounded to 0.11, rounded to 3 decimals, and that is option D over here. So sometimes you may have a question given like that, and if you don't know what kind of distribution it is, look at, do you have a fixed number of trials? Do you have 2 outcomes, like either it's correct or it's wrong? Does this probability stay the same from question to question? And also, is one question independent from another? Those were the 4 things we're going to ask ourselves. Many times, like in question number 11, all it does, it gives us like a percentage. So over here it says, according to a college survey, 22% of all students work full-time. Find the mean for the number of students who work full-time in a sample of 16. So we have over here P given, which is 0.22. We have our sample size given, which is, okay, so ask yourself, is this binomial? Do we have a fixed number of trials? Yes, n is 16. Do we have 2 outcomes? Yes, either you work full-time or you don't. Do we have person from person independent? Yes. Is the probability the same from person to person? Yes, that's the 22%. So usually when you see a question where it has like a percentage like that, it's very likely a binomial probability distribution. So look for that. The nice thing about binomial distribution is that it's super easy to find the mean and the standard deviation. So how do we find the mean? You multiply. So mean is n times p, and even though it's not asking for it, we're also going to write down the formula for the standard deviation, which is the square root of n times p times q. So over here, all we have to do is multiply the sample size times our probability. This would tell us, out of the 16 people, how many would we expect to work full time? So 16 times 0.22 is what? 3.5. So we would expect 3.5 people to work full time.